Dear students, welcome to Introduction to Nanoscience and Nanotechnology course lecture number 3rd. I'm Dr. Pervez Ahmed. So in these lectures, we will deal basically with three questions. The three basic questions which normally the student have in their mind when they are introduced to nanoscience and nanotechnology. So the first question is, what is nanoscale science? And once they know about the nanoscale science, so again they have a question that how big is the nanometers, or how we can see it. The nanometers scale materials, and then they ask a question that how did we get here? How we reach here, or how did we come to know about this kind of the material? So let's proceed towards today's lecture. At first, we have to answer about the question that what is nanoscale science. So for that, we will have a formal definitions for the nanoscale science, just like we have the definitions for the other sciences. So what is nanoscale science? Nanoscale science is the study of the object and phenomena at a very small scale. And how much small scale that should be? So roughly we said that it is between 1 to 100 nanometer. Nanoscience or nanotechnology is basically the study or the observation of the phenomena at a scale of 1 to 100 nanometer. This is the more formal definitions of uh, the nanotechnology or nanoscience. So an example of these kind of things, or this kind of material, or this kind of science, you can have once you have 10 hydrogen atom, and those 10 hydrogen atom, when you place them in a line side by side, so they measure up to 1 nanometer. You know that the size of a hydrogen atom is equal to 10 raised to power minus 10 meter. So if you have 10 hydrogen atoms and you place those 10 hydrogen atom side by side, so that all will come equal to 1 nanometer and size. That is basically the scale that is you can that how you can add up to 1 nanometer. That is 10 hydrogen atoms, when you combine them or when you place them in a line, so they will measure equal to 1 nanometer. Similarly, the most familiar example is the grain sand. If you have a grain sand, so that grain sand is almost 1 million nanometer in size. So 1 million nanometer mean that that is equal to 1 millimeter wide. One grain sand, which is most familiar example of a materials. If you took that in your hand, so that is equal to 1 million nanometer, or in other words you can say that it is equal to 1 millimeters. So again we have another question that what is nanoscale science? Is it a different science, or is it a different subject, or it is an individual subject? These are the questions which the student normally ask. So or is it a science that is different from everything? So in order to answer these questions, we basically saying that nanoscale science is by default, by itself, it is nothing. Rather, it is the combination, or rather, it is an interdisciplinary science. This is the kind of science, this is the kind of field which include all the sciences, which include all the science subject. It is basically an interdisciplinary subject. So by interdisciplinary subject, we mean that nanotechnology is a science which include physics, it includes chemistry, it includes biology, it includes engineering, it includes material science, and it also includes computer sciences. All the sciences, they come inside the nanoscience. A nanoscience is not a science that deal with an individual subject. it deal with all the sciences. I mean, all the sciences they combine here at the nanoscale. So whenever we're talking about nanoscale, so you shouldn't forget, you shouldn't be confused with the fact that only physicists can work in the field of nano. You should remember that no, it's not only the science where only the physicists can do the work. I mean, here the chemist can also do the work, the biologist, the engineer, the material scientist, and even the computer science student, they can also work here because it is relevant to all of those. And for all, the nanoscience and nanotechnology, they have application for all. So as an introduction, we can say that nanotechnology or nanoscale science is basically an interdisciplinary subject, or we can say that it is an interdisciplinary science which involve all the sciences. By all the sciences, we mean the popular sciences, and those popular sciences include physics, chemistry, biology, engineering, material science, and computer science. I mean, in nanotechnology, we'll deal with all of these sciences. I mean, nanotechnology involve all of these sciences. So how big is a nanometers? I mean, this is the second question which the people have in their mind, especially the new, the newcomer, especially the students who are new at the field of the nanoscience. So they normally ask the questions that how big is a nanometer? So for them, we basically give them example, and normally the examples we show them with the help of some photograph or with the help of some fixtures that they are being taken at a different scale. So here is a good an example. Good example. The first example is that of a human hand. They're basically of a human hand skin, and the second example is that of white blood cell. So here the first example. If you look at the first example, that is the skin of a human hand. So here, if you look at uh, the human hand skin, at a larger scale, that is 10 uh, centimeter, so you will look like this. uh, we took here, this is your human hand skin, and from this skin we take a portions. Here it's almost 10 centimeter, and here we select a particular locations, and we have enlarged that is to 1 centimeter. So you see that how the look change. This is the look at 10 centimeter scale, but now when we enlarge or when we modify it to a scale, to a smaller scale, that is 1 centimeter, so you can observe, you can see it for yourself that how the scale, how the look change. And again, if we further reduce the scale, that is from 1 centimeter to 1 millimeters, so again here you can see that how the look change. This is the same skin, the human hands skin, but how it changed with the reductions, that is how it changed with the reduced dimensions or with the reduced scale. This is the look uh, with 1 millimeter scale. So if we further reduce it, that is to 100 micron. So here you can see that at a 100 micron scale, the look is totally different that from the 10 centimeter scale. And here is another example of blood cell. White blood cell. Here you can see that we have the white blood cell which normally lies inside the skin, the human skin. So you can see it here at 10 micrometer. They look like this. It almost look like a ball, a white ball. But when you reduce, we reduce the scale from 10 micron to 1 micron, so here you can see that the look change, the look totally changed from this to this one. And if we further change from 1 micron to 100 nanometer, so here you can see it's look like some kind of the leaves like structures, or maybe some creature like structures. It look like uh, so it's a 100 nanometer scale, and we remember these are DNA structures. And if you further reduces the scale, we move toward 10 nanometer. So again here you can see it, the DNA structures look like this. And further reduction size up to 1 nanometer, that is to atomic scales. So atomic scale, you see that the structure is totally different then from the 10 nanometer scale or 100 nanometer, or then from the 10 micron scale. So I mean here you can observe that how big a nanometer is, and how the look of the material is changed by changing the scale, that is by moving from larger scale to a smaller scale. So you have practically observed that how the look or how the appearance of the material changes with the change in the dimension, that is by coming from larger to smaller, the look of the materials it changes to a significant extent. So now, again, we have a question in mind that how did we get here? I mean, how we reach here, or how do we know about these, that the look or the size of the material when I mean when it changes. So how the appearance or how the properties of the material it changes. So for that, definitely we have some tools, and with the help of those tools we discovered the properties, the excellent or the significant properties of the nanomaterial, and also we observe the significant changes that occur at the nanoscale. So in the coming slide we will discuss about those tools with the help of which we discover the significance of the nanoscales. So the first thing, I mean, that is important while seeing the object or observing the object, or with the help of which we reach to the nanoscale science, or with the help of which we learn about the importance of the nanoscale, is the light microscope. So we see we use the light microscope to see the object. I mean, where we can use the light microscope. So you know that normally with the naked eye, one can see to about 10 micron. I mean, our human eye has the restrictions. Normally, you know that we can see the object when the light is reflecting from those objects and it comes toward our eyes. So we can see only with the reflection. I mean, our eyes, they have the detectors for getting those reflections, and once that reflections they come from those objects, so we can see them. So we have the restrictions, I mean up to 10 nanometer, sorry, up to 10 micron size. So if the object size is smaller than 10 micron, so we cannot see that with the naked eye. And how much, I mean, how much small size object we can see. So this is the smallest scale up to which we can see with the naked eye. That is, we can see up to 20 micron. So the example of that is a human hair. A human hair is about 50 to 100 micron thick. So that's why we can see a human hair with the help of the naked eye. But if we have an object which is smaller than this scale, so we cannot see it with the naked eye. So for that, we utilize the light microscope. And I assume that you people might have seen this microscope in your high school when you were studying, I mean at your 10th class, or you're studying your uh, enter classes. I mean, you're doing your APC, free medical or free engineering. So you might have observed, you might have seen one of these instruments which is called a light microscope. So with the help of light microscope, I mean, one can see up to 1 micron. I mean, here you can see that with your eyes, you can see only up to 20 micron. But if you have a light microscope, so with the help of light microscope, you can see up to 1 micron. And you also have learned about the light microscope, that how light microscope work. You people have learned that the light basically bounces up of the surface, and that create the image. So here you can see, I mean, the image that is being created with the help of a light microscope. So the light microscope can have the magnification up to 1,000 times that of an act human hair, human look or human visions. I mean, naked eye, as compared to the naked eye, it can have the magnification up to 1,000 times. So it's the, I mean, it's the image of the blood cell that is 4,000 times as compared to the naked eye. So that is the 400x image of the red blood cell that you can observe with the help of, that is when you observe it with the help of a light microscope. So you know that light, they have its own range, its own wavelength, and as I mentioned already, that we can see only those objects from which the light is reflected. So you know that normally the light has its own range, its own wavelength. So what if we have the object whose size is smaller than the wavelength of the light? So what we can do there, or what we can what we can do at that particular situation? How we can see those objects whose size is smaller than the visible light's wavelength. Sometimes we can have the smaller scale object like the nanomaterials. So nanomaterial, they are basically those material whose size is smaller than the wavelength of the light. So how then we can see uh, the nano size material? This is the questions that the student might have in mind. So for that, they need they utilize the electrons. They use the electron to see the nanoscale object, because the wavelength of the electron is almost comparable uh, to the size of the nanomaterials. So the wavelength of the electron, it can be reflected from the nano size material. So with the help of that reflection or that scattering of the electrons, we can see the materials with the help of those electrons. And the device that is used for the electrons to show us the structures of the smaller scale object, we call them as electron microscope. Electron microscope is a device with the help of which we can see the smaller scale object. And the most popular of those devices is called scanning electron microscope, which in short we call SAMS. And it has been for the first time, it was invented in 1930s, and with the help of this we can see the object as small as 10 nanometer. And I already mentioned the reasons about that. The reason is that electrons wavelength is smaller than 10 nanometers size materials. So that's why electron can easily reflected from that or scattered from that. So we have detector and the device which can detect those scattered or those reflected back electron. So that normally produces, the bounces back electron from the surface. It basically create the image for us, and with the help of that image we can observe or we can see the behavior of the material. So we have high resolutions due to smaller size of the electron and its wavelength. So the smaller size of the electrons we see as, you know that how much electron is smaller. From your basic classes, you know that the size of electron is almost as small as 10 raised to the power minus minus 31 kg is almost, it's the mass of the electron. So it's very 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 small the size the electron has. The atom size, we mentioned atom is 10 raised to power minus 10. So atom has this much small, so you can imagine that electron is almost 2000 times smaller than the mass or the size of the proton or that of the neutron. So electron is significantly small, and its smaller wavelength allow us to see the smaller scale object. So for high resolutions, due to smaller size of the electron, we get high resolutions of the materials. And here is a typical look. Though it's an old model, so this is the electron microscope. Here we have connected it with the computer scale, with the computer screen. So we put the material here inside. Detailed descriptions we will give it in the coming lectures when we will deal with the characterization instrument. So this is just in short, the introduction that how we see the nanoscales material. And the nanoscale materials, we have a look. That is the resolutions, that is 40,000 times that of the optical microscope. I mean, that's how we can have the magnified image. Then we have the instrument with the help of which we can touch the surface, and they're basically called the scanning probe microscopy. I mean, scanning probe microscopy, they're further be divided into two types. One is called atomic force microscopy, and the other is called scanning tunneling microscopy. So the scanning probe microscopy that was being developed in the 1980s. I mean, it's very recently, it's almost 40 years back, and it gave us a new way to see at the nanoscale. I mean, here you see that here is the example. These are the example of the atom or the materials, and this is how you can see it here. I mean, this is the tab. This is the tab of the material with the help of which we can do the probing. And the size of this tab is, I mean, here we have the scale. The scale is about 25 nanometer. So we can now see really small thing like atoms, and even we can move them with the tool of the uh, this microscopy, that is with the help of the scanning probe microscopy. We can not only see the atoms, but we can also move the atom. I mean, this is about how big the atom is. I mean, here you can see with the help of this microscopy, we can not only see the atom, but we can also move the atom from one place to other place with the help of scanning probe microscopy. So scanning probe microscope normally come in two types, just I already mentioned. The first type is called atomic force microscope, that in short we call AFM. So in AFM, what we have, in AFM we have a tiny tap that moves up and down and responds to the electromagnetic force between the atom of the surface and the tap. I mean, just like we have this one. I mean, it has a tap like this. I mean, the atomic force microscopy, it has a tap like this. I mean, this is a typical tap of the atomic force microscopy. So it look like this. So it moves. I mean, what happened? We have this step, and this step move up and down in response to the electromagnetic force. So where the electromagnetic force come from? The electromagnetic force is basically exists between the atom of the surface and the tap. I means we move the tap up and down in response to the electromagnetic force between the atom of the surface and the tap. So the motions, I mean, as a result of that, we have the motions, and this motion is recorded and used to create an image of the atomic surface. I mean, we utilize the concept of electromagnetic force between what? Between the atom of the surface and the tip, and uh, just because of that, we have motions, and that motion is recorded to create the image of the atomic surface. So this is the concept or the principle of the atomic force microscopy. And then we have scanning tunneling microscopy, that we call in short we call that STM. So what we have in STM, in STM we have a flow of electrical current. uh, what we do with that, a flow of electrical current occur between the tip and the surface. I mean, here you can see the working principle. Here we say that in atomic force microscopy, we have the tip, and we move that tip up and down in response to the electromagnetic force. But here what we do, again we have the tip. We have the tip, and what actually happen here, we have a flow of electrical current, and the electrical current flow occurs between the tip and the surface. I mean, here we have the electrical current between the surface and the tip, but in case of atomic force microscopy, we have the electromagnetic force. We have the electromagnetic force between the tip and the surface, but here in the case of scanning tunneling microscopy, we have the electrical current between the tip and the surface. So what happened, just like we mentioned here in case of atomic force microscopy, the motion, we have the motion as a result of the electromagnetic force between the tip and the surface. We have the motion. So the motion is recorded and used to create an image of the atomic surface. So just like that, we have the strength of this current. I mean, here we have the electrical current. So the strength of this current is used to create an image of the atomic surface. I mean, here we use the concept. In scanning tunneling microscopy, we use the concept of the electrical current uh, to see the object or to create the image of the object. But unlike that, in the atomic force microscopy, we use the concept of the electromagnetic force that is being utilized to record the surface image. So, I mean, both of these, atomic force microscopy and scanning tunneling microscopy, both of these are basically the scanning probe microscopy, with the help of which we can not only see the individual atom, but we can also move them from one place to the other place. So these are the short introductions of the scanning probe microscopy. So that's all for this lectures. Hope you enjoy. So stay tuned with the next lecture. That will be lecture number 4. And again, in that lectures, we will try to answer some important questions in the field of nanoscience and nanotechnology. That is, we have to answer a question that when did nanotechnology start? I mean, we will have to study a bit of history of the nanoscale science. Then we will try to answer the questions: are there nanoparticle in nature? Then we will move toward another questions: when did modern nanotechnology start? And at the end, we will try to ask the question that how has nanotechnology developed right after its discovery. So stay tuned with the next lecture. Till then, bye bye.